Okay. All right. So welcome team, session 4 of our AgenticAI training program. So far we have learned about GenAI, the ecosystem, the platform. Then we talked about prompt engineering. Then we talked about embeddings and embedding models, how it is relevant in the GenAI or RAG architecture and what are the use cases, how they are used. So as we step into the vector databases, the next step here in the RAG application, as you can see, once you generate the embeddings, you have to store it in the vector database and then retrieve it using the semantic search, right? That's what we talked about. This is an interesting question. How do we measure the quality of embeddings, right? So embedding, as I said, depends on what kind of strategies that you use or models that you use to generate the embedding and to retrieve the vector database. The quality is in general is actually the results that you get when you search the vector database using the embeddings, right? So are you getting relevant results? Are you getting the exact all the information that you get? Are you getting asking for? So all of these, the quality of the results that you get is the quality of the embeddings. But however, the quality of the results does not depend only on the embeddings. It's one of the factors. Like yesterday we were talking about it. If you see here, chunk of text. So basically, chunking strategy plays a major role in what kind of results that you get when you query the vector database, okay, using the embeddings for semantic search results. So chunking strategy, say for example, there are various strategies. One is fixed length. As we said, 1,000 characters or 5,000 characters that you split your text using character splitters that we will see now in the demo. You are breaking the document into smaller chunks. Okay. And then each chunk you are passing to the embedding model. Suppose you are doing a report, right? Report has various sections. Some has graphs, some has charts, tables, headings, subheadings, and all of that. So let's say you are doing by characters, and what happens is you may abruptly cut the chunk in the middle of a paragraph or middle of a section, right? Half the table information may go into one and half the table information go into another chunk. The second chunk may not have a header to tell you what data it is having. For the first chunk may have the header. So these kind of strategies, right? In that case, when you search for embeddings, it may not see the relevance in the second chunk you have in the first chunk. So strategy plays an important role. It can be fixed length, or you can split by paragraphs, or you can split by sections, you can split by pages, chapters, whatever it is. So that plays a major role. Then comes your embedding, choosing your embedding model. As I said, how complex is your data? Is it image recognition, voice recognition? Do you need a huge model with 5,000 plus dimensions, or you just need a smaller model, simple text kind of a thing, 300 or 500 dimensions that you choose, right? And as I said, chunking again, once you chunk, do you want to have an overlap between the previous and the current one? We'll also revisit when we do the complete RAG application about the chunking and all of that strategies. In the next week, we will discuss chunking strategies and all of that and complete RAG application. So the overlap between the first and second, which gives you, hey, the last 10% or 20% of the first chunk, you repeat in the second chunk so that you give a common thread between these two, that these two are related or continuous chunks in the original document. Then if you do by sections, it is easier to retrieve. Then again, how many results are you retrieving? came when you say, we'll see today, when you send a query to vector database, you can choose how many results, how many nearest neighbors you want basically. You want the top 3, top 5, top 10, whatever. And when you get that, that's what you look at, how relevant are these results to your query. This also goes back to your actual optimization, basically. When you have once you get these results, that's just a semantic search, and you get the results, you throw at it, and you do whatever you want with those results. But when you make it a complete track, send it to the LLM model, here you have to send the relevant results. Or let's say you are taking top 10 or top 50 results and throwing at LLM, you are sending a lot of information, which is again defeating your purpose. And you get a lot of tokens, and it's causing a lot of processing and then lag and then cost, everything, right? So you have to make sure that you don't send too many results. So you have to choose, you want not too little, not too high. Top, okay, how many results you want to send to the model? Is it 3? Is it 5? Is it 10? Then you can also use a read anchor in between to reprioritize the results that you are getting, and also checking for the relevance. So all of these are part of your optimization. How do you make sure your quality of the model or quality of your RAG is good? Okay, so long story short, it's not just one parameter, as I said, it's a trial and error. And then looking at the quality of the output, you go back and you tune all of these parameters. What is the chunking strategy? What is the chunking size? What is the overlap? What is the embedding model? What are the dimensions? What are the top K results that you are getting? Are you re-ranking and reprioritizing those results? What is the vector database you are choosing? That also plays an important role. What kind of indexing you are choosing within vector database? And then what algorithm you are choosing to calculate the nearest neighbors, the relevant results. So all these parameters play an important role in your RAG architecture. Okay. Is that a good enough explanation?
Yes, sir.
Awesome. So remember, these kind of things, even if you are discussing with anybody or in an interview, they'll ask you, how do you make sure your RAG architecture is performing well? Or how do you reduce the number of tokens? Or how do you make sure the quality of results is good? So these are the things that you should talk about. 5 or 6 steps that you would do to make your RAG application performant. Okay. Now, with that premise, let's get back to the vector database. So yesterday we talked about, we also did a demo of how to choose how a embedding model, what it does, and how to generate embeddings from the input. Okay, and then we have in memory calculated the distances between these embeddings, and then showing how each sentence is relevant or related to the other sentence using the distance. And we have seen that similar sentences have smaller distance between them, and irrelevant sentences are having greater distance because they are farther away in the n-dimensional space when they are plotted using the embeddings. Okay. Now, once you get these embeddings, as I said, we'll go to the vector database and store it, where you can, you don't have to do this every time. Every time the user asks a question, you don't have to go reprocess this PDF, get chunk of text, create embedding and store, right? This is the initial setup part or a different pipeline. It can be your part of, data pipeline that you take to make sure you store your or prepare your data, or data store, knowledge base, whatever you call it. You don't normally do it every time, maybe not daily or monthly, whatever. If you're taking the same example of HR, right? So the policies don't change every day, or there are no modifications or no new policies. So once you start with existing all of the policies you put, maybe annually some things are revised. You update your annual, change in policies, documentations, benefits, all of that, and then you update your knowledge store. But this is done once in a while. So this part is the actual the regular chatbot application where the user can ask question and then you respond with the results. Okay. What we see here up to this part on the left side, the top one is the setup, the bottom one is the user interaction up to the vector database, and the right side of it, this part where you pass the results to the LLM model, will complete your RAG application, chatbot application. So up to the vector database, it's called semantic search application. So today we will see how far you can go to semantic search, and after that it's just adding an LLM model and then sending your results to the model to answer the question. Okay. All right. So what is a vector database? So vector database is it's kind of a similar to normal or whatever databases that we talk about, but it has a capability to index, store, and provide access to structured and unstructured data alongside its vector embeddings, which means you can store the vector embedding and you can also store its corresponding structured or unstructured data, which means your text, right? The actual paragraph that we are talking about when you convert it into embeddings. So it can store both together with metadata, and then you can get back the results, response back with to search with the embeddings. It allows users to find and retrieve similar objects quickly at scale in production. Okay, so that's the definition of a vector database. It's more like our normal databases with a capability of storing the embeddings and their related structured or unstructured data. Got it? Any questions? Okay. So this is what happens when you look at a vector database. You have a content, you pass it to embedding models, it generate embeddings, it store in vector database, and then from the application, you query the vector database and then it responds back with the results. But if you also look at here, both the content and the application, which means the user application, the question, are passing through the embedding models. So this thing you have to make sure is that you should be using the same embedding model to convert your question into an embedding, which you have used to convert the actual content into embedding. Okay, so because each model has its own algorithm and generates the embeddings based on its own training, its own algorithm. So if you are using a different model, one model to generate embeddings for the source data and one model to convert the user question, they do not match, or basically they don't follow the same algorithm, so you don't get good results when you search for the database. So it is a requirement that you use the same embedding model for the user question, the one you have used for converting your source documents or source data into the embeddings and vector databases. It also follows basically that logically that if you change the embedding model, you have to redo all of your content, right? You have to refresh your database, update your embeddings, all of them using the new embedding model that you are using to convert the embeddings and update the embeddings for the content. Or if you are choosing to change your chunking strategy, then also you have to refresh everything. I mean, truncate or remove all of the existing embedding data collection and then redo it, because the chunk changes, its embedding changes. So you cannot just update the embedding, you also have to update the content in that case if you change the chunk. So it's more like you're truncating the table and doing the full refresh kind of a thing when you change your chunking strategy. Change your model. If chunk stays same, you can just update your embeddings kind of thing. Okay. Yes. Who's this? Somebody raised their hand. Hello? No? Somebody raised their hand?
I don't see anybody, Harold.
I don't know who this Zoom user is. Oh, oh, Nabi is here. Good morning, Nabi.
Hey Harold, good morning.
Nice. Okay, so traditional search versus semantic search. I think we touched upon this a few times. What is the difference between our RDBMs like SQL Server, MySQL, Oracle? We store the data and then we kind of query the data and then get the response back. And why do we have to use the embeddings? Can't we just store this in a database and search for it? So the main difference is the semantic, which means it store the embeddings, preserve the context, the meaning of the entirety of the sentence. Okay. And it can give you the relevant or the similar kind of results rather than the exact. The closest you want to do whenever in similar in traditional search is you use like. Okay, like percent, you do dag, caught, wolf, like we're talking about, right? So if this is how the data is plotted or stored, indexed in your vector database based on the embeddings, now we know cat is here, dog is here, wolf is here, apple and banana are here. So if I want to search for a animal, I want to see what are all the animals that you have in the zoo, say for example, or in that doc in the wherever the animals are referred in the content. So in a traditional thing, you would say like percent dog, percent cat, percent wolf. You have to list all of the animals. You cannot say like animals, right? Unless, of course, you have a relevant category, and then you put under animals. These are all the ones, and then you have um, a row for each of them under the category, and you search by category. So that is by design. Now, if you add a new row, then you have to also set up everything and then put it in that category, and then you have to change your query again to add that. However, if you add a concept in the semantic search, if you just put animal is converted into an embedding, and then that is searched some in the indexed space to see who are the nearest neighbors for the animal. So by context or by training of the model, embedding model, where it has seen animal closest to these cat, dog, and wolf, the nearest neighbors will be these ones, not apple or banana, something like that. So that's how the semantic search works. It is easier to search by meaning, by context, rather than by the exact text that you need. Somebody has asked a question. Let me check. Embedding models are not the same. Why is it in two different embedding models and vector embeddings? Girish, two different boxes. in the previous slide. Okay. Let me see. Oh, this one we're talking about. So embedding models and vector. See, embedding model is just a model that you are passing your information to. Embedding is the actual data that it is spitting out, the generated data that it is sending out, that you are storing into vector database. Vector embeddings is generated by the embedding models. Then you store it in the vector database. That's it. There's no duplication to that. It's just like a factory, right? So you pass your content, it gives out the embedding for each of this, and you take those embedding and store it in the vector database. I hope that is clear. Okay, so this is about the semantic search, right? That's what we are doing here in the semantic search. Searching in the n-dimensional space on your embeddings. Now, I know I selected a model, I have the dimensions, I got the data, or I got the embeddings. Now I'm storing in the vector database. So how do I create an index? And how is the vector database able to search, calculate distances, and search from these things? So in the vector search, what happens is calculating the distances, right, between 2 points. So there are few of these algorithms that we see. One is the Euclidean distance. There is a Manhattan distance. There's a cosine similarity, and then there is a dot product. Again, these are the algorithms that vector databases use to calculate the distances or the scoring between two entities. So these two entities can be the items within the database or between the query and all the items in the database. So Euclidean distance, so as you can see here, the definition, right? Say calculates the straight line distances between two vectors. It ranges from 0 to infinity. 0 represents identical vectors and large values represent increasingly dissimilar vectors. So there is a straight distance between these two. Of course, when you say straight, it's not just a straight line because again, we have to continuously visualize. This is just 2 dimensions. And we are talking about across 500 dimensions to calculate the distance, right? And then or 1000 or 1500, whatever is the dimensions of the model, that it is generating that you saved in the vector database. Then you have Manhattan L1 here, and it's sum of the lengths of projections of the line segment between the points onto the coordinate axis. So it will straight draw the lines with the axis and then calculate distances, straight line distances, projection of that line. And again, the range is 0 to infinity, vectors, larger values. So you just have to understand that there are these algorithms. You don't need to understand how the actual calculation happens, all the algorithm and everything. But you should know that there are these 4 different types of algorithms that databases use to calculate the distance. Now, as we go back, when we said the quality of the results, right? So this is also one of the factor, or you have a tune, lever that you can tune to see what kind of results you are getting when you search. Suppose the model or the collection, the vector database is using cosine similarity, and you see the results are not very good, then you can switch to dot product and see. Sometimes you can just switch the algorithm, sometimes you cannot. So you have to create a new collection and ask the vector database to store it and then use dot product to get. Or you can create 4 collections and write the same data into all of them and use different algorithms to give the same input and see using these 4 different algorithms what kind of results are you getting out, the k nearest neighbors. with Euclidean, with Manhattan, with cosine, with dot product, and then compare and contrast these results and see which one is giving you the best result. Okay, so cosine just calculates angle between the products. Dot product actually calculates both the angle and the distance between those orthogonal vectors. Okay, so these are four of the algorithms that vector databases use to calculate the distances. Yesterday we looked at, right? Yesterday when we were talking about in memory, we use the sentence transformer model. We use in memory, we calculated the distance using the same cosine similarity yesterday. The same thing, the vector databases also use one of these four. Some of them have an option choice to select, some of them don't. OpenAI's ADA002, the model, right, that we gave, it uses cosine similarity. MiniLM hosted on Hugging Face supports cosine similarity, dot product, and Euclidean distance. So all of these three, it supports that model to search for the distances. Okay. Now it is basically a difference. I mean, how each model or vector database supports to do the search internally based on the embeddings. Now, what are different types of vector databases that we have? Just like we have Oracle, MySQL, SQL Server, MongoDB, SQL, NoSQL databases. There are various vendors that give you the vector databases as well. So some of them have purely only the vector database. Some of them have both traditional SQL based, NoSQL based databases, and additionally they can also additional capability to serve the vector search as well. So in these things, there are some open source and there are some commercially available licensed, like Chroma. If you see open source, you can use for free. It also has a license, and it has 3 different versions, flavors that you can use. LansDB, Quadrant, Vespa, Marco, Wilbus. These are all just dedicated vector databases. Same with VV8 and Pinecone. These are scalable, what you call robust, large-scale databases, vector databases for production use, commercial. Again, you can buy the license or you can source, open source, you can use for trial as well. Now, databases that support vector search, which means they already have some, they can store non-vector, I mean, normal SQL data, relational data or NoSQL data, but also can support vector search like PostgreSQL. So PostgreSQL has, we know for the data that we store, but it also has an extension for vector search called pgvector. That is the product from PostgreSQL that it can support. There is OpenSearch, there is ClickHouse, there's Cassandra, which can also support. And commercially also available Elasticsearch, Redis, Rocket. There are many more. There are a few of them I have got from the graph. These are the ones, some of the vector databases. What we will do, we will explore 3 databases, vector databases today. But when we go to RAG, we will add more. So we can look at FileDB, Chroma, and Pinecone. These are the 3 databases that we will look at, vector databases. But it's not like we go and open and see the database, use how to use these. There's another one called AstraDB from DataStax company, which now is an IBM company. IBM has bought it about 6 months ago, 6 to 8 months. So there we can go and look at the database, and Pinecone also we can go and look at the database tomorrow, and then see how you store the collection in the database. When you create a collection, what options are available and all of that. Okay. So we will actually go and look at that. Some features, we'll just skim through. FileDB wrapper on the FIS. So this has been Facebook, like Meta has been using in the Facebook for its search, right? So it needs to know nearest neighbors is calculating the relations, right? So you might know this person, this might know this person based on their connections, the graph kind of a thing. So it has this similarity search FIS, and then they wrote a wrap around that to make it a FIS DB, Facebook AI similarity search. So this we can use for RAG to add documents to FIS index and query the index for similar documents. It supports custom embedding models, pre-processing functions, and other customizations. Chroma DB, as I said, it comes in 3 different flavors. One is, it's an open source application database, easy to build LLM apps in it. It can run as a server and provide Python, TypeScript, SDKs to interact with the Chroma DB to get the request and response based on your query. So it has 3 flavors: ephemeral, persistent, and client server mode. Ephemeral is in memory. Suppose you install it in your notebook like we are going to see now. You run it, it stores in the data, it creates an instance of the database in memory. You store the data, you come out, if you run and come out of your program, so it's gone. Okay, it's temporary in memory. Persistent is same as ephemeral, but it will store that on your machine, and then you can bring it back when you want to, when you restart it. Okay, it's just like file in memory. It's gone after the program, and file you store on your machine. So next time you can read from that same file from where you left off and then work on it. And the third version flavor is client server on the cloud, basically. In a licensed version, you can just like store, retrieve, and do everything from the cloud. So that is the about the vector databases. Any questions before we jump into the action? Look at how we use the vector databases to write embeddings and do the search. Questions?
One question regarding that is shown the RDBMS query and the vector query. So
Yes.
do we have like kind of a standard syntax to search it from, I mean, do the semantic search like traditional search? Something like concepts, question, whatever here is written. So is it like a standard across the vector DB, the way we have like where select these keyword for RDBMS across like Oracle
Yeah, so
SQL?
there are no keywords for semantic search. All you send is only the embedding. That's it. The embeddings and the number of results you want. These are the 2 parameters you send for search. How many results you want? Just like in SQL, you say limit 10, limit 50, top 100, same thing. So here also you send how many results that you want to see and the embeddings to search on. Those are the 2 parameters that you send. The metadata will send you all the columns in that collection. Basically, if you have an ID, of course, you need the actual text of the chunk, and then the distance or the score between the query and the result that you're getting.
So here the question is metadata or this question word?
No, question is not metadata. Question is you send the embeddings. The question is first converted to embeddings, and then that embedding is what you send to the search query. Okay, it will have 2 parameters. One is the embedding and one is the top K. Those are the 2 parameters only it takes for search. In result, right, response, when it gives back, it can give you the metadata, the embedding, the distance, and all of that.
Okay, I mean, still I'm a little confused. So this concept is
Okay,
animals.
don't go by the actual syntax here. There is no syntax. It is just to make you understand the difference between how you are searching. you don't do the search, you don't give this query, you don't form any JSON, you don't form equal queries, you don't write anything at all.
Okay,
Okay,
all
for
that.
vector database. You don't need to write anything. This is only just to differentiate how it conceptually looks like when you want to do a search. Okay, you don't write these queries if you are, that's what you are looking at. You don't write any queries for the semantic search. Okay. We'll see now. Okay, that you'll get more clarity once you go here. So let's start with the simple one, FireDB. Okay. Now all of these notebooks, I will post it. All you have to do is, I hope you have a Google Colab. I mean, just Gmail account. You can just start open Google Colab, and then import this notebook, and then you can run it. That's it. Of course, if you need keys, you need to have the keys. But at least for FireDB, if you're not using an OpenAI model, you don't need. If you're using open source, you can just use it, import and use this. So what I'm doing here, Fire's CPU library and sentence transformers model. Fire's CPU I'm using as a vector database to store the embeddings. Sentence transformers, yesterday we have seen, this is the library that has the models to generate embeddings from Hugging Face. It's free, so I'm using this. Now, as I said, there's always a prompt you can use to generate the template code. You don't need to write any of this code. So let's say you want to write a code, just say generate code to connect to store vector embeddings in FireDB and do semantic search. That's all you need to do. As I said yesterday, you also have a Gemini here. You click on this, you get Gemini prompt. You can ask, you can give a prompt here. It will interact with this notebook. If any issues, troubleshooting, any suggestions, it can directly write to this notebook, suggest the changes, and then ask you to accept and run and everything. So you can use it as assistant directly here, just like GitHub Copilot that you are using in any of the IDEs. You can also use this here with these notebooks. Okay. We will also see one of that. Now import Fires, NumPy, standard libraries, sentence transformer model that we use. And like yesterday, I am taking 5 sentences and creating embeddings. So today I'm using a different model called All MPNet Base V2. Yesterday we used All Mini LM V6 something, that model. So this is another model that I'm using for embeddings. Okay. Now same thing, you have the model.encode sentences. This will give me embeddings, will give me the all the embeddings. And then I'm converting this to a NumPy array, these embeddings, and data type is float. You know those numbers that we have, right? And we know the embeddings shape. So what I'm doing here, so this is just for, we have to know when we are writing to a vector database, it has to know what is the dimensions that we are creating, right? So we know the model has a specific dimension. Yesterday it was 384 or something, right, for all mini LM. So we need to get what is for this model, what is the dimensions that is creating. So the shape will have the dimension and the embeddings. So if I get the dimension, I will create an index flat L2. So if you go to FireDB, it has different types of indexes that you can create using that vector database. So the simplest one is index flat L2. And then we pass what is the dimension of the vector. Is it 300, 500, 1500, whatever. And then once you create the index, you add these embeddings to the index. So that's all. That's the setup that you do, that to generate the embeddings and to store. So let's run this. Or did we run this? No. Oh, it's going to fail. Okay, that's right. So first we will run this to install the needed libraries. Okay, once the libraries are installed, then you run this, the sentences using this model, create embeddings, and store the embeddings. So what is the model that MPNet base weight 2 is generating? Let's see.
So where is that FASSDB connections or where that database, the vector database?
It's all in memory.
Okay.
Within this notebook memory in kernel, or whatever is the runtime, it's storing everything in memory. So once you disconnect this runtime here, it's all gone from the memory. Okay. If you see here, it is doing this generated.
So one question. So in every notebook, we need to execute that first line source sentence transformer.
This one.
This sentence transformer in each notebook we need to install, or it where it will be stored after installing.
Yeah, in every notebook, right? So it's all in memory. Once you come out of
In memory.
runtime, this is all gone.
Okay.
Part of your application. Even if you write in Java or any application, first you write import, right?
Yes.
And then you have jar files. If you have
Yeah.
already built your jar file locally and have it on your machine, it uses that. If it is not there, you have pom.xml or whatever, you run it and download it. In Python also, every time it imports. If it is not there, you build it, it will try to import, update. If it is already there, it will use. See, requirement already satisfied means Google Colab already has some of the existing libraries, so it can use directly from there. If it is not there, it will download the new other libraries that are not part of the Google Colab runtime environment. Okay. So dimensions is here. We have not print dimensions. So let me just add print dimensions. Just dimension. See, this is 768, the dimension. Okay. Let me go and check. That's what it is saying. All MPNet is the two. So see, all mini LM L6V2 yesterday we used is 384 dimensions. So today we are using this. It's 768 dimensions. Okay. Pradeep, can you be unmute, please? So if we go back here and see dimensions, so embeddings.shape of 1, it has first it will give you the shape of 1 is the dimension, and then it will have the actual embedding. So the shape dimension is 768. So that's exactly what the transformer model here is saying in the documentation, 768 dimensions. So using this, now, okay, we have done created the embeddings. We have added with this index and added embeddings to this FIRE's database index. Okay, now this is ready. We can go and query this. So to query that, we have to write a retriever, which can actually go search your database and get the results back. So we write a function called semantic search, where you pass your query and top K. As I said, it takes only 2 parameters. When you search, one is your query that is already generated to embedding, and then top K, which is how many results that you want to get. So first what we do is the same thing. Whatever query you are getting, first you encode using the same model. If you go up here, You used the same thing, model.encode. You encoded all of these sentences. Then same model.encode you are also doing for the query that you are passing. Here. So first you are converting into the query embedding. Okay. Then you are converting into a NumPy array, that embedding. Then you say index dot search. So this is your retriever. The index already has the search method. What you are passing the embedding of the query. Your query you are passing, but basically converting into embedding before you pass. So the embedding of your query that you pass to search and how many results you want. Okay, I want you to search for this embedding in the vector database, and I want you to give me the top k or the 5 or 6 or 10 or 2, the nearest neighbors which are closer to this embedding. Then you get the results. Basically, you get the distance and you get the actual search and index and all of that. So you can just say for the sentence, what is the embedding and what is the distance that you can do. So you have given top k equal to 2. So once you search here, this is my query. Find sentences about embeddings. Okay. So what are all the chunks or information or records that we have in the embedding in the vector database that are similar to this query? So we will call this method, so which will take this query, convert to embedding, and I'm passing here, I want 3 results. So once it goes, you can get sentence and distance in results. That's how it works. So now this is the query. Results, I got 3 results. Each sentences is converted into an embedding. That is distance is 0.55. Semantic search is performed 0.8. There is another example sentence 1.24. So look at this, the distance, right? So we talked about the lower the distance, the closer they are. The higher the distance, they are farther apart, which are not relevant. So if you look at this, my query was about embeddings. Now, if I look at what sentences that I have put in, example sentence, embedding, semantic search is performed, FIAS is a library, there is another example sentence. So it found, I asked it to get 3 nearest neighbors, it found this. So what is the each sentence? Because it has an embedding here and the sentences is about embeddings, and this line is talking about the embeddings. The distance is 0.55. Semantic search is performed using these embeddings. So it is also talking about how the embeddings is used. So that is 0.8 distance. There is another example sentence. This sentence has nothing to do with embeddings. There is no relation, no relevance to this. So this is farther away, 1.24. Since we asked for top 3, we get top 3. So if I just say, get me only 2, I don't want top 3. This is how you tune. Now you're seeing, hey, the results are not relevant for me. So this information is not useful. So I reduce the sentences. Now see, automatically the higher distance one is gone. So you get the closest ones, 0.55, 0.8. Now both your results are relevant, talking about the embeddings you are querying. You can also talk, I want to get 4. Okay. So you got 4. 1.24, example sentence, another example sentence, 1.24, 1.28, this. Now let's say I don't want to filter this here. You can use a re-ranker after this. Pass all of these results and your query to another model and say, hey, this is the query I have. These are all the results this one is sending. Can you re-rank this, cache it or re-rank it before you send it to another model for going through all of this and responding. Okay. So you're not sending to the actual model to respond. You can do a re-ranking and shuffling and filtering before you send it out based on the distances or based on whatever. So here you can get embeddings and say, hey, this is fine. Let's see, my distances are 0.8, 0.59. So I can filter this entire results by distance and take only, which are less than 1. So that is also high quality, right? So those are the things that you can think about in optimizing. If you want to optimize any of these, such results from the embedding models from the vector database. You got it? So what it is using here is Euclidean distance to calculate. Index flat L2 is what we have used, the collection. So it uses a Euclidean distance model. Lower distance indicates higher similarity, query embedding and stored embedding. So remember, Euclidean distance is one of this one it is using to calculate the distances. Any questions? This is FastDB is good, but it's all like file based. It's pretty complicated. Not complicated, I would say it's easier to use, but not recommended for production scale data that if you have huge data to work with. Okay, let's look at the next one, that is ChromaDB. Any questions before we move forward?
So one question regarding indexes. So indexes, we define like how to create. We just use some predefined.
Each vector database comes with a predefined mechanism for creating their own indexes. Some of them give you a choice to select which type of index you want to use when you're doing vector database. Some give you the default. So that is more for the tuning and kind of the speed that the vector database uses to search within. It's just like our SQL also, right? You create indexes for faster access, getting the responses, right? Faster search. You create indexes on a particular attribute, we are searching with that. Similarly, vector databases also like the collection, they create an index based on the algorithm that they have, so that when you're searching with embeddings, you get faster response using those indexes. There are two levels of storing the data. One is the index, and then there is the search mechanism. Index is basically how you structure and store these embeddings within the vector database. How do you organize, like plotting this, right? Where do you store? So this part, where do you put this information in the database? Organizing this, all of these using the embeddings. That algorithm is your indexing. Once you put it in the space in the database using that algorithm, this is to calculate the distances between, when you are searching. So this is the storing index part. This is the searching part that it uses two different algorithms. If you look at, you can go and read, I think, indexing create vector database. Okay, vector indexes to enable the approximate nearest neighbors, ANN, right? That's what we are trying to see. Who are our nearest neighbors when you do a search, semantic properties of your data. So these are the three index types again, which can be configured based on collection. When you create a collection, you can choose. This is VV8. Other vector databases will also have similar options. So you can use flat, you can use dynamic, and you can use HNSW, hierarchical navigable small world. This is a graph-based index that organizes vectors in layers of efficient traversal. It is high performance and memory intensive. So it uses a lot of memory and high performance. So it's suitable for large data sets where query speed and high recall are priorities. Flat is simple disk-based index that performs a brute force search across all vectors. It like if you give one vector, it will go and search all the vectors in the vector database and calculate distances. Now, obviously, if you have a huge database, it's going to cost more for every query. You are going to calculate distances with all the data in the vector database. It's like full scan of the table if you think like that. It's useful for small data sets, but it's efficient because you are not skipping any of the data. You are doing brute force. You are doing actually calculating for every record in the database, and then you are getting it and prioritizing based on the distance. Whereas HNSW will do a graph based, and it will only reach those nodes which are needed based on this algorithm. Dynamic is it will start as a flat and converts to HNSW automatically when the number of objects exceeds a specific threshold. You say, it's okay. You take this, you until my data is small, use flat. After that, you move to HNSW. When my number of records in the collection goes beyond 10,000 or 1 million, you go for HNSW. Otherwise, you do a brute force calculation with every record. So these are different types of algorithms or mechanisms that vector databases use to store the data, right? To plot, to put those embeddings in that n-dimensional space. The first part. The second part is how you calculate the distances between these two data points, between the user query and the data in the database. Understood? And there also you can do more reading how indexing works and all of that. What is HNSW, how it works and all of that. Does that answer your question?
Yes, yeah, I got it. Thank you.
Great. Awesome. All right. So now we have got that. Now we are doing is ChromaDB. I'm installing ChromaDB in memory. So I'm using the ephemeral client, which is in memory, and importing that and creating a client. So this client is the ephemeral client. And then I am creating a collection called cohort 6 collection in this.
This collection is actually encoding or something else?
What do you mean encoding?
I mean, in earlier model, we are using encoding, right, before creating embedding. So is it same thing?
No, we have not gone to embedding at all. See, this is a vector database. It's think about it like I have a database. Now I'm creating a schema or a table. I have not put the data in it yet. Okay, there is a database, which is Chroma database. There is a collection. Now, when I create embeddings, I'm going to store in this collection in the ChromaDB.
So
just like you have schemas and tables, right? That is what I'm creating here.
any name you can use.
Any
That is
name
not-
you can. Yeah. It depends, right? So if your organization has different things, let's say you are storing both finance data and HR data in the same vector database. Obviously, you don't put in the same collection, right? You create different collections. You say HR collection, you say finance collection, you say a customer support collection. That's like schemas or tables to differentiate between the kind of data that you have. And once you create a collection, each collection you can use different indexes. Okay, and different models, embedding models as well. And you can do multiple things. So again, for the collection, I'm adding these documents and IDs here. Okay, I'm not doing any, if you see here, I'm not creating any embeddings here. I'm just adding the data directly to the collection, to the vector database. Okay. But we have said, hey, we cannot write the actual data to vector database. We have to always pass it through embedding model and convert it and then write to database, right? Then how are we going to write this? So let's see what happens if I write this to a vector database collection. Okay, there's no error. But if you see here in Chroma, Onyx models, there is already a embedding model which is hosted within the database as a default model. So like last time we did here, we can create a model, use the, not create, we can use the embedding model, generate embeddings and store it, or we can use a default model that is hosted within the vector database. It will automatically convert it into embeddings and store it. We don't have to do it explicitly if you want to use the default model on the database. However, this is not recommended. You should always explicitly use. I'm just showing you the different options. Same thing if you do this, right? I have not used a model. So my collection query also, I don't need to convert to embeddings. Chroma will automatically embed this for you. Okay. So if I run this, it will automatically convert into embeddings and then get the result. ID 5, ID 3. It's a beautiful day in Hawaii. The weather is nice in Hawaii. These are the included values, the metadata, document, and distances. What is the distance? 0.59. So the question I said is, tell me about Hawaii. The response I got is these two. It's a beautiful day in Hawaii and the weather is nice in Hawaii. So obviously both are talking about Hawaii, and then the distance is 0.59 and 0.69. These are the result that I'm getting. And exactly this sentence is not there. Tell me about Hawaii is not there in this. Okay. I don't have that exact sentence here. So it's just searching based on the similarity, based on the embeddings it has generated, and based on similarity that it has, it's storing in this and then getting the response based on the embeddings and the score. And then I have asked it to get 2 results here. How many results you want? I said 2, you get 2 results. Both of them are talking about Hawaii. Okay. Now, I want to put in something like a sentence called it's freezing. Okay. As I said about weather, and I want 5, let's say I want just top 3. Okay. And I run this. So if you see here, I get it's cold and windy. I get the temperature is very low. It's a very harsh winter. None of these 3 sentences have a word about freezing. Okay, but still, how did it choose these 3? The distances are smaller when compared to weather is nice in Hawaii, or beautiful day in Hawaii. Summers are hot and dry. Why didn't it pick these sentences?
Because those are close to freeze, like winter, that's why.
They are very far. Hot and dry is very far, completely opposite.
Right.
So, a lot of distance is there.
Yeah.
And again, top 3 on that.
Yeah. So basically, when you generate the embeddings, right, as I said, it understands the context and the entirety of the meaning of the sentence, meaning of the data rather than the actual words. It's not a standard algorithm that, hey, always freezing is this number, winter is this number. It's not like that. It understands the context and the meaning and it generates the embedding. So even if the question does not have anything about weather, just freezing, it does not have any of this in freezing. It understands if it is cold and windy, it might be freezing. If the temperature is very low, it may be freezing. The harsh winters can be freezing. So these are the top 3. Now, if I ask it to get top 5, now I will get all 5. And you will also get distances. But you see, this is where you need to filter. It's a beautiful day. It has returned this as well, but the distance is more, 1.37. Summers are hot. It knows like if it is freezing, it's not a beautiful day, right? So that's why the distance is more farther. And summers are hot and dry is, as you said, exactly opposite of freezing. It's 1.4. Now, if I get more results, I'm asking it to give me 10 results. I have put 10. Now it will give you all 7. Okay. Now weather is nice in Hawaii, beautiful day in Hawaii, which has nothing to do with what we asked freezing. I have not talked about Hawaii at all. I don't want to know anything about Hawaii. But since you asked me to return 10, it will return all of at least 10. Okay. Whatever is the data that it has. And it will also give you the distance. Now this is where you can filter how my results are coming in. Let's say if 3 is enough, or 5 is enough, or 7 is enough, based on multiple queries and the responses you get and the distances you are getting. So based on the trial and error, you have to then tune your application to get whatever you need here. So that's how the semantic search actually works. The main difference between your traditional database and the vector database with the semantic search, normal search versus semantic search. Now you asked that question, right? From this here, you said, like, what we put here, question, embedding, and all of this. See, we don't do anything here. This is how we kind of do a query for vector search. You just pass in your query and top K. That's it. You don't write any other SQL. You don't write any format, anything at all. Everything is taken care of by the retriever or by the vector database.
So it's based on context, it's searching?
Yes. It's based on context. Embeddings are generated based on context and
Context, yeah.
the embeddings to do the search. It's not doing a context when searching. It's already there in the embeddings. So the embeddings already have that context. So when you do the similarity search, it's because based on the embeddings, you get the similarity search. Okay?
Yeah.
All right. Any other questions before we continue with one more? We are using...
It is going to do ranking internally based on the ascending order distance.
It's not
Or
ranking.
just-
Giving you the distances. You do the ranking based on the distance.
That's
Some
about this.
models give you the distance. Some models give you a score between 0 and 1. They
Okay.
based on the distance, that ranking. Or you can do explicit rankings. As long as you know the distance, right? Smaller distances are closer, larger distances are farther. So based on that, you just assign the rank order by the distance ascending. That's it.
So, like, is it right to say, like, a smaller distance will come at the top always?
Yes,
As a
exactly. It should be. Smaller distance means they are closer to each other, right?
Yeah. So in the result, like, it's always like the smaller will be on the top.
No, it's not like that. It can be. So that's what you have to use the distance to select. If you want to further filter and select only based on the rank, you have to do it. You have to write the code to select by that order, having closer. That's why I said top K you can reduce. You can just say top 3. But when you pass it further into a RAG architecture, you pass it to a LLM model, it will not look at that ranking. It just takes whatever 3 records, 3 paragraphs, 3 chunks that you have thrown at the model. It reads all of that and it reads the actual question and just it'll answer from that. Now, the context that you are passing to the LLM model, okay, that is what you have control over, what you are passing to the model. Should I pass 10 paragraphs, 10 chunks? Should I pass 5? Should I pass 3? If I want to pass only 3, how do I make sure the 3 I'm passing are the top ones? That you do it based on the semantic search results. Either you can do top 3, it will automatically give you the top 3 smaller ones. But within those 3, if you want to re-rank, you can do it. Okay. All right. So I'm using here Pinecone. So tomorrow we'll explore more about Astra DB and Pinecone DB, all of that. But today we'll use the Pinecone and create indexes and do this, clear all outputs. And I'm installing all these libraries, unstructured, tick token, LangChain. See, till now we have not done chunking. So now I'm introducing the chunking concept. Like I take a document, I will split into chunks and then create embeddings and then write it to the vector database. So to create the chunks, I'm using PyPDF2 to read a PDF document and then split it. All of these are NumPy, .env to load LangChain library and NumPy. So we will read more about LangChain in the coming sessions, and OpenAI for the models. Okay, tick token, unstructured, all of this for processing the document. This is the boilerplate code. Okay, that you need to run with. You need to run to generate the chunks kind of thing. Okay, standard Python code. Now I have run this. Let's say if I'm running this, what happened? Text splitter is throwing an error. Okay, so all of this is just boilerplate code. So what I'm doing here is I'm getting OpenAI API key and Pinecone API key. So Pinecone, as I said, it's not in memory. It's on the cloud. You can create a trial account. I will also add that to the configuration document, how you can go and create a Pinecone vector database and get a API key account and get an API key to work with it. As I said, I have keys here. OpenAI key, Pinecone key. I have enabled these two. And this is how I'm reading those keys here. os.environment of OpenAI API key is what I'm getting from these keys. User data.get. You will get these keys and I'm assigning it to the environment variables. And then I am also getting from environment again. Of course, you can directly do this here. But this is all boilerplate code. Just setting up the keys, making sure they are available in the environment, so environment variables, setting up all of that. Then I'm importing this Pinecone from this API key. I'm passing environment. I'm passing Pinecone environment. So this is where you have created your Pinecone vector database. So I'll show tomorrow when you create a vector database, you have to select a cloud environment like either AWS or Azure, whatever they are available on the cloud. You can choose one of them and create. So use that environment here. And then I have created an index, semantic search fast. So first time, if you don't have, you can enable these two. If it is not there, to create index, you give the index name. And dimension also you have to give how many dimensions that you are creating for the collection. Basically, I was talking about, right? Say if I'm using mini LMV6, I give 384. If I'm using all MPNet 786 or whatever, if I'm using OpenAI model, I'm using 1536. So you have to give the dimension, the name, and spec. You don't need whatever that spec is. Where is the spec? The spec here, but that's fine. So you create this index in the Pinecone environment. Once you have that index, then these are the boilerplate code to read the file and split it in chunks and store it. So you're using a PDF writer from the file path, and then you're extracting all the text. Then you're passing that text to text splitter. So this will split based on a new line character with the chunk size and chunk overlap. So chunk size I am passing, I can pass later. Overlap I am passing 100. See, 20 characters, chunk size is 100. This is default. I can overwrite that. And then you are splitting it into chunks. Then I will pass those chunks to this. I'm using this model, embedding ADA002, which has, I know, 1536 dimensions. Okay. So I'm passing that embedding ADA002, all of these texts to generate the embeddings. And once I get the embeddings, I will upsert or insert into the index. This is all boilerplate code. Okay, just how you are reading your documents, splitting it into chunks, generating embeddings, okay, and then writing it into vector database. This is the question. If I have a question, I pass the question, then again call same embeddings for the question, and then query the index with my query embedding, top K, how many results I want, and include the metadata. So it will return the results. Now, I ran this. I'm getting this error. It says no module named langchain.textSplitter that I'm using here, langchain.textSplitter. So I don't know what's happening with this. Now I'll just go and say explain error. So it brings up the Gemini model here, and it will read the context, read this code, figure out what is the error, and then it will suggest what I need to fix. So it has said, hey, langchain.textSplitter is no longer available. You have to use, it was not found. This is likely due to changes in the library structure. I will fix the import statement to use langchain community.textsplitter. So instead of langchain.textsplitter, now you use langchain community.textsplitters. So it's basically, you say, you can use here Gemini to understand the context and say none. All you have to do, you can either accept, cancel, or accept and run. So I will just use accept and run. So it has automatically changed this to langchain community.textsplitters, and it's running this. So this is all like we are writing the methods. It's not actually doing anything, but it has compiled all the code. We have all the methods to load the document, to create chunks and generate embeddings, and then update the chunks into the index, and everything is here. So that is done. Now what I will do, I will update I will use my PDF file, my resume, is a PDF file, and then load the PDF and create the chunks. Okay. And then I can also do print chunks here, how it is generating. So we got an error here again. Let's see. Okay. So it says no such file or directory. So we have to provide the path, right? It's not able to find the file here. So what I will do, I'll go here and upload the file. So I'll just, this is my resume file that I am using. So it will upload, it will say warning that files are saved elsewhere. This runtime's files will be deleted when this runtime is terminated. So it's kind of temporary. So you upload this, you run this, and then when it is done, it will delete the file. I said, that's okay. I'm just using it for now. So the file is uploaded here in the default directory. The path of that is this /content/my resume. Now I go back and run this. It should be able to read that file and generate the chunk. Okay. So it has created a chunk size of 149, which is longer than the specified 100. It kind of automatically suggested, okay, based on the document that you have, based on the paragraph you have, it has overridden, which is longer than you specified 100, but it took a varied size of chunks based on the structure of the document from its own intelligence in the LangChain text splitters. So it created one with 149, 139, 306, 150. If you want, you can actually override that as well. But these are all the chunks that it has. So it's all not readable here because it's using \n and all of that. Let's see. And now I'm using this question here. What are the certifications? I'm asking the question now that it has generated all the chunks and then uploaded. I will ask the question here. What are the certifications? So it gave me the chunks basically. And this is one chunk. This is another chunk. Recognition, professional. See, it's breaking here. It starts with professional. It starts with recognition. It starts with AI engineer associate. It starts with in adapting new systems and processes because it has a certification and recognition here holds, right? So it gave me these top 5 responses, results. Okay, and this is the output. If you look closely, right? So this is what it throws at you, the results. But if this is your application, okay, let's say this is your application, you have built the knowledge base, you have built the vector database, you're getting the relevant results and throwing at you. But is this readable for the user? If I ask a question, can I make sense out of this information? I know the information is available in this, but I cannot make a sensible information out of this. Correct? Do you agree with me? If I give this kind of response to the user, will he be happy? I said, hey, this is all the information. No. You go and look at it. There will be whatever you need will be in there. Okay. So you are throwing some information at the user again and for him to figure out things. So if I ask a different question, what are the projects that you have executed? Okay, so it gives you data platforms, regularly communicated project, large-scale digital transformation. These are skills, processing, architected, developed applications, Azure. All of this. Again, it doesn't make sense. I'm asking about the projects. Where are the projects? So it's just throwing me some information with the score, right? So this is where the next part comes in, where you add your LLM model. Till this point, you are only using embeddings to dice and slice your information, generate embeddings, store in vector database, get relevant results based on your question. I asked about projects, I'm getting this information. I asked about certifications, I got different information, right? Last time. So see, there is significant difference between what information the vector database is throwing at me based on the question. That's fine. This is all related to certifications. This is related to the projects. But as a whole, I cannot make sense out of this information. I know it is relevant. I know I have it in there, but I can't make a complete sense or can't get a perfect answer for my question from this information. So this is where you take this context, take these results and feed it to a model to complete your chatbot, complete your RAG architecture. So that model will go through the answer information that you passed, whether you are sending this or you are sending this. You send both this question and this information to the model. That is where you are augmenting the context. You are augmenting your prompt to the model to answer this question only based on this information I'm passing you in the context. So now the job of the model is simplified. It doesn't have to depend on the extensive knowledge that it has or a training that it has. Of course, using its intelligence and algorithm and training, it needs to go through this information and answer this question in a natural language processing model. Basically, how output, formatting and output based on how the user expects it in a user readable format, if you would say, best presentable format. That's what the model will be doing as part of extension to this. So if you go here, go back all the way here. So this is where your vector database is throwing out the results. Now this retrieved information, whatever means is this. This is your retrieved information from the vector database. Okay. This retrieved information plus the user query, you pass both to the model. The model will go through. See here, if you see, you have instructions, you have context, and you have query. Query is the actual question that user have asked. Context is the results that you are sending from this vector database. Instructions are like standard system prompt. We looked at, right? We said system prompt, user prompt, and AI prompt. So system prompt is basically your instruction. User prompt, you will get both the query and the context is added to the system prompt, and user prompt will have the query. Taking these three, the LLM will add the response that will complete your RAG architecture. Okay, so we will pause here. This is a logical completion or conclusion for semantic search application up to the vector database and getting the relevant results, where you can dictate the top K, how many you want, the results, and what is the relative ranking, re-ranking. You can do all of that before passing this to the model. Okay, this is all pre-processing that you do to send only the relevant information to the model so that it doesn't have to do a lot of work, process a lot of tokens, generate a lot of tokens. To simplify that, we are doing this. Say if we don't do this, if I ask this, what are the certifications? The model can still answer. I can just give the complete my resume, upload it, and then ask the question. The model will still do it. But the point is, it has to read the entire PDF every time you ask a question, all the tokens. So all those tokens first are cost, both in terms of money and processing power and time it takes. First thing. Second, it's all waste of resources, right? For the certifications, it did not read all the projects. Okay. For education, it did not read all the certifications, project skills. If that section is different, it can just read that and give you an answer. So that's where you do pre-processing and filter out the information and extract only the relevant information for the question from the vector database and pass it to the model to do the last step of the processing and answer the question. Tomorrow, we'll complete that loop, add the LLM model to this pipeline, basically, to make the semantic search application a chatbot. So once you add the model, it's a chatbot, right? You're asking a question, it's giving you an answer. It's like, you go back to, a question Q&A, just like this. So this is just vector database, but you will add a LLM model to make it a chatbot. So this will be the complete chatbot. All right, that brings us to the closure of this session. Any questions before we wrap up?
One question I have, I get clear in later session, but the key problem we are solving from this RAG with confidential data, company confidential data, right?
Mhm.
So still we are storing into vector database and we are giving those to LLM, right?
Mhm.
Maybe the summarized version or the less version. So
Mhm.
still we are exposing some data to LLM, right? So
Mhm.
how it's problem?
Okay. So there are two different aspects. That's a good question. When we say we want to give LLM confidential data, it does not have the limitation, right? The limitation of a model is that it does not have access to internal data. See, confidential, non-confidential, public is, let's put that aside for a minute. It does not have access to my data, my company data. Okay. Let's say I'm just a customer support. I want to give, washing machine, right? I'm selling washing machines, and there are some frequently asked questions. There are some error codes, say the digital, it's displaying, some you have to dust or remove some part, and some error it is throwing. Now the user does not know what it means and what he has to do. So he can call customer service or he can go to a chatbot. So there I have all the frequently asked question and responses from the user manual, maybe 100 pages, 200 pages for that washing machine, where I have explained, put all the instructions and common errors and how to fix them and all of that. So that's my data. It may not be very confidential. Okay. All you are doing is FAQs. But however, the model does not know my troubleshooting for my washing machine, uh, because I'm not sharing my financial information. It's just troubleshooting data. It's not very confidential. It might be proprietary, but not very confidential. I'm just taking, for example. But if you ask ChatGPT, it does not know unless what your model is, what your machine is, what is the exact manual for that is, and what it does. So that is what we talk about having the confidential information. Or let's say the LLM model is released in 22, you bought a machine which is the latest model in 24, which might be significantly different from what the model has been trained on previous types of machines. So that information is not there with the model. So then it's going to hallucinate or give you the wrong information based on the previous model. So we are solving that problem first. Second, when we come to security, yes, absolutely, you're right. We are still passing that confidential information. If it's not customer support, if you're talking about internal HR policies or internal financial data that we are passing, so that is definitely a security problem. Having said that, any model that you use goes through the same security pattern. First thing, even before you pass this vector database and results, there is a compliance. Basically, if you run, first it will check whether you would have access as an employee, whether you have an access to get that data. So that is captured. All of that you have to build around it. Okay. Authorization and authentication. Whatever you call that your application, the API, first it will go and check based on the user ID or based on the login or the what you call the uh, single service,
Right.
single sign-on SSO, right? So you'll say first you have the access. Only if you have access, you will go and get that. And again, in the vector database collections, you can give access based on the role, who can access what collection and what data. So all of that is standard, just like if you are accessing your relational database. Once you only have that, you send it to your LLM model. That's the level 2. Level 3 is your model is not sitting somewhere, just like I'm doing OpenAI API key and sending it. In your organization, in the production environments, you will not directly access any OpenAI. Though the OpenAI says we do not store your information, we do not use it for training purpose and all of that. But still, no company, no organization will agree to directly access and send information over the net to an outside world OpenAI. So it's always these models are installed on within your network, on your cloud. whether it is Azure or AWS, wherever your cloud you have, it will be within that internal cloud network so that your data does not go out of the network. So it works within your network. So it has a firewall. So you have a different API. You don't directly call your model. You have a different firewall and API. You call that. After all authentication and authorizations, it will call the internally installed OpenAI model or any model that you have, license, commercial license, or installed on your network. So your entire information is again within the network. It's not going out. So these are different levels of security that comes with the DevOps, with the infrastructure that you build, all of that, the compliance, the data governance. It's all part of the entire application. What we are doing is only the core. Now there are several layers that needs to be built on top of that. So that is your complete data governance, application security, infrastructure security, vulnerability. All of that is assessed before it goes into production. I hope I answered your question. Yeah.
Thank you.
To maintain this LLM, do we need to pay any additional amount?
Sorry, answer Pradeep.
So to maintain the suppose if you install LLMs in any cloud network, so do we need to pay any amount?
Yeah, you have to, right? See, currently, if I'm using OpenAI key, it is charging me based on the tokens. Directly, I'm talking to OpenAI. But for the enterprise, they have enterprise license. Let's say you are buying Oracle. Oracle, you will buy an enterprise license, and then they install Oracle on the cloud. Oracle Cloud, you will use it. Any service, if you use Salesforce, you buy an enterprise license, right? And then you have an account created, Salesforce account, and that's where your data is stored or how you use your application. If you create Snowflake, you buy enterprise license. That's how you interact with your Snowflake, and that's how you get your information back.
Suppose if the cloud is, if you are pushing our information to cloud, automatically they can misuse, right? Is it possible?
Where are you pushing? Yeah, it is
So
possible if it is directly sending to the outside network, right? Out of your network. If it is within your network, no, they cannot reuse because that particular instance is installed within your network.
Okay.
It cannot go out of your network, the data.
Suppose if you want to buy that to some of the license LLMs, we need to pay definitely cost, right?
Yeah, it's just like another any other service, right?
Software.
Yeah,
Okay.
you have to. Of course, there are some open source models that are freely available. You can take it and install on your network and use it for free. Those are like, if you want DeepSeek, it's open source. You can use it free. You can take it and install it and use it for free. Llama, you can use it for free. Okay. But again, it depends on how secure and all of that you have to take care of. All right. So I think we are good. Have a great rest of the day. This weekend we'll meet next week. We will run through, complete the RAG architecture chatbot. We will do it on use couple of frameworks to build the RAG architecture next week, and we bring it to a logical pause before we head on to holidays break, and then we will reconvene after that. So next week, stay tuned. We'll complete the RAG architecture. We'll explore a couple of frameworks and build the chatbots. Okay.
Arun,
Awesome.
initially few minutes I didn't join. So when is the break? Just want to check. In Christmas
No
time?
break. Yeah. So we will not have classes on the Christmas weekend.
Okay. Got it.
20, I think, what is that?
25th or 26th.
Yeah. So
27th,
next week
26th.
we have sessions on 20 and 21. We will do RAG architecture and complete. 27, 28, we don't have classes that weekend. The next class will be on January 3rd and 4th. Restart on January 3rd. But next week we have classes. Okay.
Sure.
All right, guys. Okay. Take care. Do let me know if you have any further questions, any feedback. Ping me on the group or DM. We can talk about. Okay. Thank you. Take care. Bye.